Today we are looking at two different triangle inequalities. One looks at how the sides and the angles connect. The other one looks at side lengths of a triangle. So first we're going to look at side lengths and angle measures. So first we'll give a little definition of what this is. And so what this tells us is that the shortest side, I definitely spelled that wrong. The shortest side is always opposite the smallest angle. And in opposite of that, the longest side is always opposite the largest or the biggest angle. So short is across from short, long is across from long. So let's look at a couple examples of this. So here in example 1, it asks us to list the angles in order from largest to smallest. So if we look at our side lengths, we've got side PQ, which is 32, side QR, which is 46, and side PR, which is 38. So if we're looking for the largest first, I want to look for the longest side. So if I look 32, 38, 46, 46 is my longest side. So if I look across from 46, I see that points at angle P. So angle P would be my biggest or my largest angle. So then we've got 32 and 38. 38 would be next in line. And if I look across from 38, I'll see I land at angle Q. And then my smallest angle, here the last one I have is 32. So then if I look across from 32, I land at angle R. So when we put them in order, we've got P, angle P is the largest, then angle Q, then angle R. So this would be our final answer. So let's look at another example. This time it wants me to list the sides from shortest to longest. So if I look here, I've got 30 degrees, we have 40 degrees, and 110 degrees. So if I want the shortest side to go first, that means I need the smallest angle. So if I look at my numbers, I've got 30, 40, and 110. So 30 is my smallest number. And if I look across from 30, I end up down here on this line. So this line is between the letters X and Z. So the shortest side would be side X, Z. Then I need the next smallest, which would be 40. So then again, if I look across from 40, I end up on this side, which is between the letters Z and Y. So my next slide, or my next side would be Z to Y. And we're putting this segment symbol above those letters so we know it's a side. And then lastly, the number we have left is 110, clearly the biggest. So if we look across from 110, we end up on this side right here, and it's between the letters X and Y. So for our final answer, shortest to longest, we would have side XZ, side ZY, and then side XY. And that would be our answer. So in this one, you're just looking at what you have and then going across to put them in order, either small to big or big to small. So now let's take a look at what is called the triangle inequality. So what we're looking at is, do the numbers given, will they make a triangle? So if we fill in this definition, what this says is any two sides of a triangle must add to be greater than the third side. So the two smaller numbers need to add up to be bigger than the biggest. So let's look at some examples. So example 3, determine if the following sets of 3 side lengths could represent a triangle. So these are all going to be yes, it makes a triangle, or no, it does not make a triangle. So first, I need to find the biggest side. So here my biggest side is 12, and I'm trying to see if I take 10 and 9 and add them together, will it be greater than 12? So when I add 10 plus 9, we'll get 19. And 19 is, in fact, greater than 12. So these 3 numbers would be yes. They do make a triangle. So if we look at B, our biggest side, we've got 7, 15, and 8. So our biggest side is 15. And I want to see, is that greater than my other 2 of 7 plus 8? So if I add 7 plus 8, oh, I did not want to write that again. What is 7 plus 8? It'll get us 15. So is 15 greater than 15? It's not greater than. These two are the same, so they are equal. If they're equal, it does not work. So this one would be no. It does not make a triangle. And then we've got one more, choice C, and we have 19, 7, and 10. So if we look, 19 is our biggest, and then we have 7 and 10 as our others. So we want to see 19, is 7 plus 10 greater than 19? So 7 plus 10 will get us 17. And is 17 greater than 19? No, it is not. 17 is smaller than 19. So we were able to make one triangle out of our 3 different choices. So what this says is if we had a side that was 7, a side that was 10, and then a side that was 19, it would look something like that. It wouldn't all touch. So that's why that would not make a triangle. All right, so we've got one more type of problem to look at. So let's look at example 4. The figure shows the approximate distance between cities in California. What is the range of distances from San Francisco to Oakland? So that is this missing number right here. You can see these 3 cities make a triangle, and we've got to figure out what could this number be. So if we're looking for a range, we want to know the smallest option all the way up to the biggest option. So we have the numbers 51 and 46. So we know if we want a smaller number, the easiest way to do that is to subtract. So what I can do is take 51 and subtract 46. And if I do that, we would get 5. And then to get a bigger number, we would normally add. So what I can do is take 51 and add 46. If we do, we would get 97. So what this says is that our possibility for x, the smallest it could be, is 5. Because here if we do 5 plus 46, we get 51 on the dot. So we know it needs to be bigger than 5. Because say if we put 6, 46 plus 6 would get us 52. And that would be greater than 51. And then, but it's got to be smaller than 97. Because if it's 97, we know that when we add 51 and 46, that gets us 97 on the dot. So if we had 98, 51 plus 46 would be smaller than that 98. So it wouldn't work to be bigger than 97. So the distance from San Francisco to Oakland must not be greater than 97. It needs to be smaller than 97. And it cannot be less than 5. So we know it's got to be between 97 and 5. All right. So now we're going to take these notes and go and try some practice. Let me know if you have any questions.